All right, so for these 4 examples, or for the one example with 4 parts to it, you have to take and find the domain for each linear piece of the function and then write the definition of the piecewise function for that graph. And actually, I think this is a little easier than going the other way. I think it's sometimes a little harder to graph given the definition. So I'm going to take you through step by step here on part A as to how I would go about doing this, and then we're going to try some together for the last 3. So the first thing that I want to do is look at the graph and recognize that there's in fact 2 different pieces. I have the piece that goes from -1 to 0, this piece right here, and then I have the second piece that goes from 0 to 2, this piece right here. So I have to go ahead and define my domain, and I think if we define our domains first, it'd be easier to write the equations after that. So the first domain that I'm going to be looking at is from x equals -1 to 0. So I got -1 to 0, and I'm going to give 0 to the first function that I'm going to be using, which means that the domain for my second function, which goes from 0 to 2, I will not include the 0 for that, but I will include up to 2. So those are my 2 domains that I'm going to use, and now I just need to define the function over those domains and write it in piecewise notation. So the nice thing, as I said, that we will only be dealing with linear functions for this particular unit, so there's no need to stress out about different types of functions that you may see. So on this first piece, going from -1 to 1, so over here, let me get rid of these lines real quick. From -1 to 1, this one over here has a slope of -1, and we can do this as simple as saying this. You know, if you draw in the little triangle to define slope, how do you go from one point to the next? You must go down 1 and then over 1. So the slope is -1, and it has a y-intercept of 0. So I'm writing a linear function whose slope is -1 with a y-intercept of 0, and that is just the function y equals -x plus 0, or just y equals -x. For the second function, I want to take a look at going over here from 0 to 2. So again, if I do it the same way, if I consider just what the slope of this linear piece is, I go over 2 and up 1. That will get me from 0, 0 to 2, 1. So I know that my slope is equal to 1/2. Again, the y-intercept is still 0. So y equals 1/2 x plus 0, or just y equals 1/2 x. So now I just go ahead and write this using my piecewise definition. F of x is equal to brace. On the domain -1 to 0, I'm using y equals -x. And that's for x greater than or equal to -1, less than or equal to 0, and y equals 1/2 x for x values that are between 0 and 2, not including the 0 this time. So there you have it. That is the definition of the piecewise function for that particular graph. Alright, as you look at B here, again we have 2 linear pieces. This time there's a slight difference. What you might notice is there is a clear discontinuity here where we have a missing point in our second function. But give it a shot. Pause the video and see if you can write a definition for the 2 domains, one from -1 to 0, one from 0 to 2, and see if you can put them together into a piecewise definition. If you're going to struggle with that, let the video keep playing. Otherwise, pause it, write it, and then come back. And when you come back, I'll go over it. Alright, so the first thing I'm going to look at is the domain -1 to 0. And the 0 is going to be in the domain of the function over here on the left-hand side. So I am going to include the 0. The second domain is for the second function, which goes from 0 to 2. Again, not including the 0 this time because that wouldn't be a function, but including the 2 at the end point. For the first function, I'm going to, again, just take a look at the slope and recognize that in terms of change in y and change in x, I go up 1 over 1, which means it has a slope of 1. So this is, again, y equals x plus 0, or just y equals x. And for the second function, this one over here, that is just a constant function. It doesn't have an x value in it because its slope is 0. Remember, horizontal lines. Alright, for the second function, we're looking up here. We want to go ahead and get a value for that, and as I said, it's a constant function. So the equation of that's going to be really easy. It's just whatever the y value is, and we see in the ordered pair 2, 1 that the y value is 1. So this is the constant function y equals 1 on the domain 0 to 2. So putting it together, if I write this as a defined piecewise function f of x, I'm going to be using y equals x on the interval x greater than or equal to -1, less than or equal to 0. And I'm going to be using the constant function y equals 1 on the interval 0 to 2. So 0 less than x less than or equal to 2. And that is how this piecewise function would be defined. Okay, hopefully you're getting the hang of this. Here we have what look to be two parallel line segments, rays, whatever they happen to be. So it looks like they are going to have the same slope. So as you go and try to define the piecewise function for this, consider the fact that they do have the same slope, and that slope is negative. Again, why don't you pause it right now and give it a shot. Otherwise, let it play through, and I will do the problem for you. Alright, so in terms of calculating the slope again, if I have 2 points, I can calculate the slope. So this looks like I'm going down 1 over 1, and in fact that's true for both of these. These are both slopes of -1. I know the y-intercept on this first one. This is going to be a y-intercept of 0. So this first graph has an equation of y equals -1x, or -x, plus 0, which is the same as y equals -x. And the second graph has the same slope, so y equals -x for it, so this one. But up here we have a y-intercept of 2. Now, even though 2 is not in the domain of that portion of the function, we still use it as the y-intercept. So y equals -x plus 2. So in terms of writing f of x, the first domain is going from -infinity to 0, because if you look, the tail on this line means that it does keep going on and on and on and on. So I'm going to be using y equals -x for all x values less than or equal to 0. So I'm not going to say between -infinity and 0. I'm just going to say x takes on any value between less than or equal to 0. We're using y equals -x. I'm going to use the second function, y equals -x plus 2. Whenever I am greater than 2, but less than 2, but greater than 0. So this is going to be 0 less than x less than or equal to 2. And there is the piecewise defined function for C. Alright, last one. Give it a shot or hang around. So again, I'm just going to look at slopes. For the first part of the function, it looks like I'm going over 1 and up 2, which means that the slope is 2 and the y-intercept is 2. So the first function is going to be y equals 2x plus 2. The second function, again, given these 2 points, I know that I'm over 1 up 1, so that's a slope of 1 with a y-intercept of 0. So y equals x plus 0, or just y equals x. The first portion of the graph is on the domain 1 to 0, including both endpoints. So this is on the domain 1 to 0. The second portion of the graph starts at 0, but does not include 0. It has the open circle. And it goes on forever and ever and ever and ever. so this one does go on to infinity. So writing the defined piecewise function, I am on the 2x plus 2 piece when x is between, oh, I missed the negative, didn't I? -1 and 0. When x is between -1 and 0, I am going to be on the y equals x piece when our function goes from 0 to infinity, so for x greater than 0. Alright, so hopefully that helps you out. If not, I'm sure you can find some other videos about writing equations for piecewise defined functions, but again, sticking with linear, I think you're just looking for slopes. I guess the one thing that I could add if you wanted to do this a different way, if I come back up here to my drawing or my graph, whenever you're given 2 points on a line, you should be able to write the equation for that line. So if you wanted to use point slope form to write an equation, you could do so. So given the points 2, 2, and 1, 1, I know that the slope m is equal to 2 minus 1 over 2 minus 1, which is 1 over 1, which is 1. And then I know the point slope equation, I can choose either of those 2 points with that slope and write it. So if I said y minus 2 is equal to 1 times x minus 2, so I'm using the point 2, 2. Getting this back to slope-intercept form, you get the equation y equals x. So if you wanted to go about getting your equations that way, given the 2 points on the line using that, you could do so. However, all of the y-intercepts were given in these problems, so there was really no need to do it that way. Alright, see you in class tomorrow.